Every single process out there, I don't care if it's in manufacturing or healthcare, it has variation. It's just the natural noise in the system. But the tricky part is that hidden somewhere in all that noise, there could be a signal that something is going seriously wrong. The real challenge is knowing how to tell the difference.
And that's the million-dollar question, isn't it? You're looking at your data, and you see this little hiccup. Is that just random noise, or is that the first sign of a huge problem? Because if you react to the noise, you're just going to create more problems. But if you ignore a real signal, well, that could be catastrophic. And this is where Statistical Process Control, or SPC, comes to the rescue. It's basically the statistical toolkit that was designed for this exact problem, to give you a crystal clear signal that separates that normal, predictable, common cause variation from the unpredictable, special cause stuff that needs your attention right now. Okay, but let's be real for a second. SPC can sound, well, pretty intimidating, right? You've got control chart constants, all these statistical rules, and you have to pick from like over 20 different chart types. The good news is that modern tools can take all of that complexity and turn it into a really simple, guided journey. The entire analysis is really built around one simple idea, a clear, structured path that pretty much anyone can follow. At the absolute heart of this whole approach is a visual workflow. And look, this isn't just a suggestion, it's a required path. The software literally walks you through it, 6 steps from the very beginning all the way to your results, making sure nothing gets missed. And here they are, those 6 steps laid right out for you. First, analysis setup, then chart type selection. After that, you'll review the data requirements, upload your data set, select your columns, and boom, you get your results. So let's start with what's probably the most critical decision point of all. All right, now, step 2. This is the big one. This is arguably the most critical junction in the whole process, picking the right control chart for your data. Because if you get this wrong, the rest of your analysis is, well, pretty much meaningless. The decision really just boils down to one fundamental question. What kind of data do you have? Is it continuous data? Things you can measure on a scale like temperature or weight or time? Or is it discrete data? Things you count, like the number of defects or just a simple pass or fail? And this right here perfectly shows the power of a guided workflow. See, you don't need to have a statistics degree. You just answer a couple of simple questions like, is your data continuous? And how many measurements do you have for each sample? The software then does all the heavy lifting and gives you a clear primary recommendation. In this case, an IMR chart. The guesswork is just completely gone. Okay, so with our chart selected, we're ready to feed the engine. This is where we go from a simple spreadsheet to a really powerful analysis, and the software makes it surprisingly easy. Oh, and this feature is a lifesaver, seriously. Before you even touch your file, this system shows you exactly what it's expecting to see. For example, it wants a column for the sample ID and another one for the measurement. This one little proactive step prevents so many frustrating upload errors down the line. So once your data is all formatted and ready, you just find it in your dataset library. In our case, we're going to select this IMR chart out file. It's just a single click and it's selected. All right, this is it, the final step before the analysis. You just map your columns to the required fields, and the system even makes some smart recommendations for you. Once you confirm the setup is right, you hit that Generate Control Chart button, and the statistical engine in the back end just gets right to work. And just like that, we've arrived. This is the moment of truth, the part where the system turns all those raw numbers into insight you can actually use. Boom. The very first thing you see, you can't miss it, is this bright red badge. There's no ambiguity, no hunting around for the conclusion. The dashboard basically screams it at you. Your process status is out of control. This is that clear signal we were hoping to find. Now, since we chose an IMR chart, we actually get 2 charts. The top one, that's the individual chart, or eye chart, and it tracks your actual measurements. The bottom one is the moving range, or MR chart, and it tracks the variation, the consistency between those measurements. Both are absolutely crucial. Okay, lean in for this one. If you only remember one single thing from this, please make it this. You always interpret the variation chart, that's the moving range chart on the bottom first. This is the absolute paramount rule of SPC.
So why is that? Well, because those control limits on the top chart, the lines that tell you if you're in or out of control, they are calculated using the variation from the bottom chart. So if your variation is unstable and all over the map, those control limits are totally meaningless. You'd just be chasing ghosts. You have to have stable variation first.
Now, the analysis doesn't just stop at the charts, not at all. The results are broken down into different views, starting with this really clean executive summary. It's perfect for quickly getting your stakeholders up to speed on the key takeaways and what needs to be done.
And then, for those of you who really need to dig in, other tabs give you a full breakdown of process performance, capability metrics, an analysis of the violations, and even a list of best practices that are tailored to your process. It's incredibly comprehensive. But what if you're looking at all this and you still have a specific question? What if you're stuck on what a particular finding means? Well, this is where the tool has one last, pretty incredible feature.
Yep, there is a built-in AI assistant. I mean, think of it like having your own personal PhD statistician just sitting right there next to you, ready to answer any question you have about your specific results.
Let's just look at a perfect example. A user might ask something like, hey, why is my variation chart stable, but my main chart has all these violations? The AI gives a crystal clear answer. It means your process variation is consistent and good, which means those violations you're seeing up top are real signals. Those are true shifts in your process average that you need to go investigate. I mean, that single insight right there is just incredibly powerful. So that brings us to the final thought here. When a complex statistical method is made this simple, when the path is so clearly guided, and when you've basically got an AI expert on call, what problems that have been hiding in your process data for who knows how long could you finally bring to light?